Okay, so let's review a bit about inverse functions. I think you probably remember we basically just swap the x and y coordinates. So for example, y equals 3x plus 1. Let's see what that does. Okay, that looks all right. So 3x plus 1, you'll get this equation here. Now, just to interpret this a bit, see if I can use my pen again. Yeah, this doesn't really have a great pen function, but it's all I got, so we'll try it. So if you want to think about this equation, y equals 3x plus 1, let's just interpret it again. Okay, now this is your straight line equation, and they all look like this. And they're all in the form mx plus b or ax plus b, or mx plus c actually is one that I see a lot, or ax plus b. It doesn't matter what we call it. Anyway, so the m is the slope. So that's the slope. The c is the y-intercept. So let's just talk about graphs first to help you graph them better. So the slope is going to be 3. Okay, and the y-intercept is going to be c, which is 1. That's this number here. You see how the green line touches 1? So that's your y-intercept. That's 1. That's the easy thing to do. So if I want to graph this by hand, I will find the y-intercept first. I'll mark this point, and then I use this slope. Now, the slope that I told you yesterday is written as rise on run. Rise on run. And this number is 3. So that's the same as 3 on 1, because 3 on 1 is 3, isn't it? That equals 3. So the rise is 3 going up. So rising is 3 and running will go left or right. So rising 3, running 1. So what I do here, it doesn't matter which one I do first. So if I do rise 3, so rise 3, 3 units. You see that's 3 units, right? So rise 3, go up 3, and then you run 1. And 1 is positive, so you're going in the positive direction. I'll show you a negative 1 soon. So rise 3, run 1, and you'll come to this point, won't you? So you see this point and this point are on the line. So then we just draw our line straight through like that. So you'll always get this some kind of triangle drawn here. It doesn't matter where you do it. So we could go rise 3, look at this, rise 3, run 1. Rise 3, run 1. They look like steps, don't they? So this would be really hard to walk up. Imagine you're standing here and you're trying to walk up that. So you're going to have to kind of climb up the stairs, aren't you? Like for really short people, going to be a big problem. So 3 is quite a steep line and it's positive. It's going up in the positive direction. So positive direction. Okay, because it is a positive number like that. But if your graph is negative, so y equals, let's do a harder one, minus 2/5 plus 2, like that. Okay, so let's think about this graph here. Y equals minus 2/5 x plus 2. So y equals minus 2/5 x plus 1. When we come to coordinate geometry in semester 2, we'll do this again. So this is just to get you used to graphing straight lines. Okay, so take it your y-intercept. Oh, plus 2. You see that? That's the y-intercept. Intercept, which is this point here, yeah? Okay, now this is the slope, minus 2x minus 2 on 5. So that's the slope. Okay, and this is the slope. So this is the rise. This is the run. It doesn't matter whether the negative is the top or bottom. I'll leave it on the top. Okay. So now your rise here is negative. So you're not going to go up, are you? You're going to go down because it's a negative number. So this is telling you to go down 2 units, but go across positive 5 units. So negative direction. So this is negative direction, DIR, and this is positive direction, DIR. So we go down 2. So now we're not going up, we're going to go down. So use your y-intercept and go down to here. So that's your minus 2 because you've actually gone down in a negative direction. And this is telling you to go 5 in the positive direction because it's plus 5. Okay, so you've got to follow the direction from that sign there. So then we'll go plus 5 right to there. And that makes sense because now we're on the line again. So you have this point, this point. So this is plus 5 and that's negative 2. So if I see that, I know the slope will be the rise, which is negative because you've gone down on 5. Okay. You could go this, you could go in a different direction, but you'll still go and get the same answer like this. So down 2 across 5. But if you went backwards, you'll get the same answer, won't you? If you go from this point to this point, you'll be going negative 5 and up 2. You see, it doesn't matter which direction you go, you'll still get a negative number. So down 2 across 5 or negative 5 up 2. So negative 5 plus 2. So that's one way you can get your graph. That's probably the harder way to do it, but it's the way that you need to learn how to do anyway. So we'll go back to inverses. Let me go backwards and forwards again. Let's just make up some stuff because I'm not with you personally. It's actually like more difficult. So I have to kind of give lots of examples. All right, so go forward again. It's easier than erasing the board. Let's make up some equation again. So y, let's use that one we had. This y equals 3x. So it's going to go up plus 2. That looks all right. So this is 3x plus 2. Now we want to write the inverse of this. So let's just write on this again. And I can't find another free program that does this. So we got to bear with this GeoGebra anyway. Okay, so we've got a line. This is your function, fx. And that is 3x plus 2, wasn't it? You can take notes if you want or just pay attention. So 3x plus 2. Now I want to draw the inverse. I'll label that here somewhere. X. We'll get the equation later. Don't worry about that yet. But we can still draw it, can't we? Does anyone remember what we do? Can anyone tell me? We talked about it the other day. What do I do with this point then? This is 0, 2.
Change it to 0.
Right, good, 2, 0. So you only need to swap X and Y, right? So 0, 2 becomes 2, 0, and I can't change this color, I don't think. So we'll stick with black. I'll learn a bit more about it later. So 0, 2 becomes 2, 0, which is here, right? And then what's another point? This one here, because the others are not actually on a corner of the block, are they? So we'll pick that one that's easy, that one. So this is 1, 5. And 1, 5 becomes 5, 1, doesn't it, down here? So you have enough to draw the line already. Okay. Now that's going to go through. Look at this point here. -1, -1. So when you swap -1, -1, it would be -1, -1, isn't it? So that point doesn't change. So that point is actually going to be touching on both. So I don't know how good my handwriting is. So let's draw your inverse like that. So put your inverse in. You got a ruler, and I'm sure you're quite good at drawing straight lines in your program. So continue that. But think about now, look at this here. This slope, let's look at this slope here. This was 3, wasn't it? We're going to have a problem with this point. I can't read this point here, but we can do the slope anyway. I can't tell exactly what that's going to be. I can show you how to do it soon. So this would be 3, 1, right? So your slope is rise on run. So across 1, up 3. So 3 on 1, which is 3, which is good. That's that number. But what about this one here? Can anyone see? What would be the slope of this line? That will continue down through somewhere here. This is 1, isn't it? This is 3 units. 1, 2, 3. This is 3 units long. So our slope for this line is rise is 1, run is 3, 1/3. Okay, so this would be 1/3 x. X. What do you think this number is, anyone? Does anyone want to guess? What's that point there? It's between 0 and -1. What do you think? Does anyone want to guess the fraction? What do you think? It's more than 1 -1/3. -1/3 would be about here. So maybe this is minus, I think this is about -2/3. I'm going to write that there. We can check that later. We can work out what it is. So trying to do graphing and then finding this point, very difficult. But we can use a method for doing that. I'll show you that later. So this is -1/3 x. I think it's -2/3. We'll check that later. Okay. So all you need to do, I think that was Nicole that said, all you need to do is swap your points. So 0, 2 becomes 2, 0. Like that. And any point, -1, -1 swaps to itself. So, and remember our line y equals x would go in the middle. And that would be our reflection line. Remember we talked about that yesterday. So this line, this point will reflect across to here. So it will jump from here and it will jump to here at a right angle and the same distance. It's getting messy now. Anyway, but that line, I usually ask for that line here. So let's go back to our actual book. So you can take rough notes about this. Let's go back to our file here. Okay, so this is question 3. Let's go back and look at question 2 quickly. So this is from yesterday. So we had our function, which is 3x plus 1. That's here. And this is our inverse function here. And I didn't calculate the equation yet. And we have the same problem here. We can't see where it cuts the y-axis. So we can't see the y-intercept here. Don't worry about the equation. I just wanted the graph anyway. Okay, that's that one. We did that yesterday. So look at the next one. I get my panning hand to work there. Okay, look at this one here. What I did already, I already put in the y equals x line, and I worked out how to do that yesterday. So let's make it smaller so you can see. All right. I'm actually using a different tablet now. You can see this. So I plug this into the computer and it will show actually everything on the computer. So if you do digital art, this is the best one to have. It's my wife's actually, not mine. She got from her work. But they're like about 20,000 baht. So they're pretty expensive, but they're really good if you like art, digital art. So I recommend to get one of these if you can. But I like the pen better on this one than the one I was using, the small one I'm using. That's like 3,000 baht, which is still expensive, I guess. So anyway, so this is our line y equals x, which is here. Remember, 2, 2, 4, 4, 6, 6, 8, 8, like that. So I get my line, y equals x. You could also write that as fx equals x, if you like, because this is the line, this is the axis y equals fx. There. And this is x down here. I haven't put it on. Anyway, so we want to draw this function here, the square root of x minus 3. So you're going to actually need a calculator. So when you're doing this, you can do this with me. So let's make a table. Let's write the equation first. So fx equals x minus 3. So it looks like we can go from 3. So if x equals 3, and you put 3 in here, you'll get root 3 minus 3, which is root 0, which is 0. So your first point is 3, 0. Okay, so you're going to get some in your worksheet a little bit later. 3, 0. So that is 3, 0 here. Okay, that's that point down there. You see that red dot? That's 3, 0. Now, the other ones are going to give fractions, so they're kind of messy. So what if it was 6? Let's go to 9. Let's go to 9. So what if x is 5 minus 3 is 2? That will give you root 2, which is a decimal. It's a bit messy trying to work out the decimal. We want 4, so 7. So if x is 7, I'll get 7 minus 3, which is root 4, which is 2, isn't it? So another point is 7, 2 here. So we've got 3, 0, and we've got 7, 2, which is about here. So 7, 2 is there. The other one would be 9. That would be 12. So if x is 12, let's go up a little bit. So if x is 12, we'll get square root 12 minus 3, which is root 9, which is 3. So another point is 12, 3. That's all I'm going to do, because the rest you need your calculator, and then you need to estimate where the point is. It's a bit difficult. So my other point is 12, 3, which is here. You see, it doesn't go up very fast, does it? Because it's a radical function. So go in. There, that's the other point. So your graph is going to be here. And just do it by hand, okay? So I'll use red for the function. And I haven't gone below. I've just gone from here. That's all I've got to show. And it will keep going up slowly like that. Okay, so this is your function. So can you draw that in your tablet? Or if you only have a piece of paper, you need to sketch it and get the idea. Get the idea, okay? So this point here was 3, 0. So let's write them in. 3, 0. This point was 7, 2. And this point was 12, 3. You see, I didn't bother with the other numbers because there would be fraction or surd numbers, and you can't really estimate easily on the graph. So just go through your 3 points, and this will be your function. This is root x minus 3. Like that, okay? So that's your function. And that's what you had to draw, one thing you had to draw. So that's f. So when I write f, it means fx. And this is f inverse. I just didn't put the x in bracket there. So let's keep that in. Let's keep the function in yellow. That's this one here. Okay, that's your function. So I hope you understand. If you don't understand, let me know. Because if you don't speak, I assume you can do it. Okay, so that's your function. Now the inverse function, remember we swap x and y. So let's do this in green, but I don't think it shows up as green very well. Okay, so 3, 0 becomes 0, 3, which is here. 7, 2 becomes 2, 7. 2, 7 is about there. Right, and 12, 3 becomes 3, 12. So it's gone way up to here. So it kind of looks like a quadratic, doesn't it? But only part of a quadratic. It actually, that's what it is, but we'll look more at that later. So this will be your inverse function here, and it will come down to here. So let's write that as f inverse x. Not worried about the equation, okay, at this time. We can calculate using algebra. So this is going to be your inverse, so I'll put that there. And we put the line y equals x in already. Let's do that in blue. That's meant to be blue. What happened there? That's blue. So this is your line y equals x. And remember, I said that these points reflect across this line. So if you put a mirror here and you look in the mirror, you will see this line here. So if you come across, I've got to turn myself around a bit. Let's use red, but I'll use dotted lines. So this will come across to here. Then this one, 7, 2, 2, 7 was here. So that will come across to this point. I usually don't require you to draw these. It's just help you draw the graph later for some question. So they come down. I try to make a right angle with this black line, the y equals x line, and come down all the way. Now, if you were to measure this length is equal to this one. This length is equal to this one. And this length is equal to this one. I just made them different dashes to show their different lengths. So that's how it works. So that's how you get your inverse. And I did ask here for the domain and range. So let's, I'm going to clear this out. So look at the two graphs and look at the domain and range. So this is an important idea too, what I'm going to talk about now. So we've got our function. Let's do this one. This is fx. This is your function. Now, what's the domain of this graph? What do you think? Can anyone tell me the domain? Remember, domain refers to the x-axis and range refers to the y-axis this way. What do you reckon? Domain. X is a member of what? You're only here, aren't you? I assume you can do this and you're just too lazy to answer, I hope. So your domain is going to be from 3, which is the lowest point, which is okay. You can use 3 in here. You can use 3 in here and get 0. Root 0 is 0. That's okay. So you're going from 3 to positive infinity. I've just stopped here, haven't I? The graph will keep going. I just haven't actually stopped it anywhere. So it's going to go from 3 to infinity. Like that. Now, what about your range? Let's make that y, because y refers to the range. So range is referring to this area here. So we're going to go from 0, aren't we? From 0. Now this line will keep going up in this direction to positive infinity. It's very flat. It'll go up, but really slowly. Okay. And the more you go, the slower it gets as well. But it's still going up. It's not going to go flat. There's no asymptote here. The graph doesn't stop. Even though it looks very flat, it's not going to be a flat line. It just goes up very slow. So it's going to go from 0, which is okay, to positive infinity. You can put positive on them like that. So keep that in mind. That's for your function, which is here, domain and range. Now look at your inverse function. Now that's actually still a function. And I've got to talk about other things later. Some graphs are function, but when you do the inverse, you don't get an inverse function. I'll talk about them later. Let's keep going. So look at this one here. So let's do your domain there. I want to keep that one in the board. So how about your domain here? Remember, your domain refers to the x-axis. There's nothing on this side, is there? There's no graph over here at all. It stops here. You can't have negative here. The graph cannot go this direction because you'll end up with square root negative number here. So there's no graph here. So that means your domain here would be from 0 to positive infinity. Your graph is going to go in this direction. It's going up, but it's still going to the right direction, to the right side. So it's going to go from 0. X is a member of 0, and then up into infinity, like that. That's your domain. What about your range? So this is kind of review, so hopefully it's helpful. So now the range refers to the y direction, the y-axis. And you can see the lowest point is here, which is 3. And we can include 3. And the graph is obviously going up. So from 3, that should be square bracket too, square. So we're going to go from 3 to infinity, and infinity is never included because it doesn't stop at any particular number. But what do you note here? Can you see that there's something the same between these two? Your domain here of your function is the same as the range of the inverse. That's not a good color, is it? I'll do that in blue. You see that? Your range here of your inverse is the same as the domain of the function. They swapped. The range and domain swap. That's very important because you will come across this again. So your domain of your inverse is the range of the function. So we can say that the domain and range swap between the function and inverse function. Any questions? So you can take some notes on your, this is actually the answer, this is required. So you should copy this domain and your range for the inverse, okay, or for the function and inverse. And this is important here. So I do talk about that, I think, in the worksheet later on. Okay. And that happens because remember you swap X and Y. If you swap X and Y, the range and domain have to swap as well. Okay. So that kind of makes sense because we are swapping X and Y. But I want to write on this, I want to draw on this graph again and put a couple of other things. Oops, let's erase all of this. I shouldn't have rubbed that one out because I want to talk about something else before the next section. my graph is gone. Oh, well. Let me just sketch it in again. So it went that way, and it went that way. So remember, this is your function, and this is your inverse. I just want to talk about something a little bit different now. It's related, obviously. So remember, this was 0, this was 3, 0. This was 0, 3, like that. And then they swapped over. So if you had a point, so let's think about this. So this would be f. This is telling me that f3, the x value, will give you 0, won't it? Don't worry about what the equation is. f3 equals 0, yes? But on this one, f inverse 0 is 3. Do you see this relationship here? When you put 3 into your function, you'll get 0. But when you put 0 into your inverse, you'll get 3. Do you see how those two numbers swapped around? So that's quite important, actually, important idea. So we could write that as, let's call this XY or AB. Let's call this AB. And this is going to be BA, isn't it? Because remember, they swap. So AB, BA will swap. So we could write a rule here, which I'll talk about in a minute. So if we have FA equals B from the function, we can relate them using this double arrow here. You'll learn more about that later. But it's just saying that these two ideas are related. So FA equals B. That actually means if and only if, but that's another topic for another day. So they're just related. So FA is B, F inverse B equals A. Like that. So keep that in your mind when we go to the next section. So if I said, for example, f minus 3 equals 6, what can you say about the inverse? What would you write here and here then? Anyone? What do you think? So if you put minus 3 into your function, you get 6 as the answer. What would you write here then? Think about this here. What goes here then? It's got to be 6, isn't it? Because we swapped x and y. So FB equals minus 3 with no graph or anything. I just know that these two numbers are going to swap between the function and the inverse function. So if you have F2 is 12, that means if you put 12 into your inverse, you'll get 2 as the output. I don't need a bracket there, that one. So if you put 2 in your function and get 12 as the output, if I put that 12 into my inverse, I'll get 2 out. That's how they relate. So you should actually write this rule somewhere. It's in your book, but quite important. So can you copy that somewhere? That's how the values relate between your function and your inverse function. Okay. That there. Can you copy that down somewhere before I go up? And that's what it's talking about on the next section.